All right, let's look at a couple more graphing and writing in all three forms. Okay, so we're going to graph this function and then write its equation in three forms. So we have the intercept form right here, okay? And intercept form, remember, you look at it, it's got parentheses in it. And so we know that the standard form doesn't have parentheses in it. So we figure if we're going to go from intercept form to standard form, we need to get rid of those parentheses because, yeah, standard form can't have them. So we need to multiply, right? Because that's what those parentheses really mean, is they mean multiply. So let's go ahead and multiply this out. And the other word we could use for that would be called expand. So we're going to expand it, right? We're going to go from factored form to standard form. So this is really just multiplying. It's stuff we've done. You can use FOIL or you can use the box. So I'm going to make this nice and big so I can have plenty of space to write. So, don't want to do that. Okay. X minus 3 and x minus 5. Okay. So, got the box here. Oh. Okay, so we had 2x minus 3 and x plus 5. Actually, we'll just do it right here. So, to multiply these out, you could use FOIL or you could use the area model, which we call the box. So we have x minus 3 and x minus 5. So we just multiply each of these together and then we add up everything inside. So x squared minus 3x minus 5x plus 15. So this from factored, go ahead and make that a little smaller so you can see this. From factored, we have x squared minus 8x plus 15. And again, that was this part right here. That's those two multiplied together. So we still need to multiply this too. Now, if you look at it, that's it still has multiplication in it, right? It still has parentheses, so we need to take care of those. We need to multiply everything in so that the parentheses are completely gone. So that's going to be 2x squared minus 16x plus 30. So let's come on up here to standard form and we can write that in. 2x squared minus 16x plus 30. All right, so that's our standard form. And now we just need vertex form. So vertex form, we find the vertex and then we just write it. Okay, so let's start by finding our axis of symmetry. Our axis of symmetry is negative b over 2a. So that's negative 16 over 2 times 2. So that's 16 over 4, which is 4. Okay, so our axis of symmetry is at 4. So then to find our actual vertex, we need to put 4 back into our original equation and figure out what y equals. When x equals 4, what does y equal? So let's do it. Honestly, it doesn't really matter. Like, we could put it in our intercept form or we could put it in our standard form. And I think it's going to be easier to put it in our standard form, or I mean our intercept form, because, like, look, that's actually going to be really easy. So we have 2 times 4 minus 3 times 4 minus 5. So that's 2 times 1 times negative 1, which is negative 2. So when x equals 4, y equals negative 2. So our vertex form, we know our vertex is at 4, negative 2. So to write vertex form, we have f of x equals 2x minus 4 squared minus 2. So our a value stays the same. Our vertex, remember when we put x in, anytime we're graphing x, it's a liar. So see how it's inside the parentheses with x? That means instead of writing a positive 4, we're going to write a negative 4. And then we're going to have our y value out here. So we know that our vertex is at negative, or is at positive 4, negative 2, and our intercepts are at positive 3 and positive 5. So we can just graph it now. From here, we can graph, we go to positive 4, 1, 2, 3, 4, and negative 2 right here. And then we know we intercept at 3 and 5. And there you go. There's a parabola. And its equation in all three forms. So there's that one, and we already had that one. All right. Let's look again. Last one on the graphing. Okay, so we've got it in standard form. Let's figure out what the vertex is. But this one's tricky because do you see that there's no like b value, right? There's nothing that in front of x. So let's figure out what that is. That means A is 2, B is 0, and C is negative 2. So let's find our vertex. Well, our vertex is negative b over 2a. So that's negative 0, which is just 0, over 4. So our x-coordinate of our vertex is 0. So our vertex is at 0, something. So let's figure out what that something is. Well, when x equals 0, what does y equal? So we plug 0 in here for x. And we get 2 times 0 is 0, minus 2 is negative 2. So the y-coordinate of our vertex is negative 2. So our vertex is at 0, negative 2. So if we want to write this in vertex form, we have y equals, our a value is 2, x minus 0 squared minus 2. And that's it. And it's actually, you don't even need that 0 in there, so you can say y equals 2x squared minus 2, which happens to also be our standard form, which is kind of tricky. But really, it's just, so this tells us that our x-coordinate of our vertex is 0, and the y-coordinate of our vertex is negative 2. So now we got to go to intercept form, and the best way to do this would be to factor it. So let's try factoring. So it needs to multiply to negative 4, because a times c. Actually, we need to do something first. Do you see there's a common factor? When there's a common factor, we have to pull it out. They can both be multiplied by negative 2 or divided by negative 2. So you always want to look for a greatest common factor first. Okay, so now we have our 2 pulled out, and we need to multiply to 1 and, multiply to negative 1, a times c, and add to 0. So that would be 1 and negative 1, because it was multiply to 1 and add to 0. So this is y equals 2 times x plus 1 and x minus 1. So that's our intercept form. That means that it crosses at positive 1 and negative 1 and has a vertex at 0, negative 2. So we just go ahead and graph it. Our vertex is at 0, negative 2, which is right here. And then it goes at negative 1 and at positive 1. And we know that it would go to those points, right? Because we go over 1, up 2, because of this 2 in front of here. Over 1, up 2. So then, there you go. All right, let's solve a few quadratics really quick in this video. So we're going to solve these quadratics with any method you choose. So basically, factoring, okay, let's start with this. What are the 3 ways that we know how to solve quadratics? Well, there's 4. Okay, we can solve quadratics, get this bigger, by graphing, factoring, by square root, and by the quadratic formula. Okay, now for this test and for the stuff we've been doing now, graphing is not realistic because you have to graph every single one of them, and it just doesn't make sense. So we're not going to be doing it solving by graphing. We are going to be doing these three here. Now, just so you know, factoring works sometimes if it can factor. The square root works sometimes. The quadratic formula works all the time. Every single time the quadratic formula works. There's never a quadratic that you can't solve with the quadratic formula. The problem is the quadratic formula requires a ton of algebra, lots of multiplying by negatives, lots of square roots, so sometimes it gets really hairy. So if you can factor, I would suggest trying to factor first. But if the quadratic formula is what you know and that's what you want to do, you literally could do that every time. Okay? So let's take a look. This one is there something that multiplies to negative 48 and adds to 9? I don't think there is. So I don't think it factors. So let's just use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so we have x equals negative 9 plus or minus 81, and then 4 times 4 is 16. 4 times 4 times 12. 4 times 4 times 12 is 192. And since this 12 is negative and this 4 is negative, we actually have 81 plus 192 all over 8. Let's see, plus 81. Alright, so this is x equals negative 9 plus or minus the square root of 273 over 8. And I don't believe that we can take the square root of 273 any further. So that is your answer right there. Negative 9 plus or minus the square root of 273 over 8. It's not pretty, but it works. Okay, so let's look at the next one. Is there anything that multiplies to 2 and adds to 2? The only thing that multiplies to 2 is 2 and 1, and it adds to 3. So, looks like this one's another candidate for the quadratic formula. So, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have x equals negative 2 plus or minus, and then you just start simplifying. So we have 4 minus 8 all over 2. Oh, maybe there is something. Did I miss something? I don't know. Oh, nope, I see. Okay. I was like, man, that's going to come out really nicely. But do you see that? Do you see? You probably don't see because my big head's in the way. Okay. So, 4 minus 8 is negative 4. Okay, so now we have the square root of negative 4. Well, what's the square root of negative 4? It is 2i, because the square root of negative 1 is I, and the square root of 4 is 2. And so we're going to have, well, plus or minus 2, but we already have the plus or minus in there. So x is equal to negative 2 plus or minus 2i over 2. And then you notice that all three of these can be divided by 2. They all can be reduced. So we have x equals negative 1 plus or minus I. That's our final answer. Okay, so that's it for this video. I will do a couple more with a few more examples.